All right, this set of virtual notes, we're going to talk specifically about surface area of prisms and cylinders, okay? Remember that prisms have two parallel and congruent bases, okay? Those bases are polygons. And the lateral faces are parallelograms. Okay, most of the ones that we see will be rectangles for surface area, but that does not mean that they can't be just a regular parallelogram either, okay? And when we name prisms, they are named for what shape their base is, okay? Now for all prisms, regardless of what polygon their base is, our surface area formula is 2b, all right, because there are two bases. So we need two areas of those bases, plus capital P, capital H. Okay, now what these variables stand for. Capital B stands for the area of the base. All right, so you first have to identify what shape the base is first. Because that is going to direct you to which formula to use. Okay. Capital P stands for perimeter of the base that you chose. So whatever shape you find the area of for the capital B, you will find the perimeter of the same shape. All right. Capital H does stand for height of the whole prism. Okay, but a good question to ask yourself is how far apart are those bases? Okay, so we'll do we'll probably do these three examples together. I want you to take a little bit of time to try the fourth on your own, but then we'll go through it. Okay. This first example, our base is a rectangle. All right. The top, and then what is the bottom, I guess, that you can't see right now. Okay, to find the area of a rectangle, since a rectangle is a parallelogram, we use base times height. Okay, now these are lowercase because we're talking about just the dimensions of the base. All right. So when we're finding the area, we're only going to use the numbers that are attached to our two bases. Okay, 6 times 2. The area of our base then is 12 square feet. Okay. Now, capital P, we are finding the perimeter. All right, and remember, the opposite sides of rectangles are congruent. So if we have 6 and 2, we also have 6 at the back side and 2 on the left side. So our perimeter, 6 plus 2 plus 6 plus 2, tells me that my perimeter is 16 feet. Okay, and then capital H, remember, stands for the height. How far apart are those bases? Okay. We're going to use 2b plus ph and just substitute these three values into that equation. Okay, so 2 times the area of the base that I found plus the perimeter of the base times the height. Okay. When we do that, we find that the surface area of this rectangular prism is 216 square feet. Okay. Number 2, we have a triangular base, okay, even though the triangle is not on the top or the bottom, okay, the front and the back face are the exact same. Identifying that base first tells us that to find the area of the base, we need to do 1/2 times base times height, okay? Now remember, the lowercase b, lowercase h, we are only going to be pulling numbers from one of the bases. Okay, now that back base doesn't have any numbers on it, so we can ignore it. But the base of our triangle is 6. The height of our triangle is 4. So those are our two numbers that we're going to use to find the area of the triangle. Okay, just like if I gave you a triangle with 4, 6, 5, and 5, just looking at that two-dimensional shape, the 5s are not helpful for the area of the base, okay? But 1/2 times 6 times 4 tells me that the area of my base of my triangle is, coincidentally, 12 again, okay? To find my perimeter, now I'm going to add the sides of the triangle, okay? So we've got 5 and 5 and 6. That tells me my perimeter is, wow, 16 again. How ironic. Okay. Capital H is the height, but remember the height is how far apart those bases are. So from the front triangle to the back triangle, we have 11 centimeters. Same equation, 2b plus the perimeter times the height. So 2 times the area of the base that we found, the whole area, plus the perimeter of the base times the height of the prism. And this gives me 200 square centimeters for the surface area of this triangular prism. Okay. Next one, we have our base here is this right side. It is a 6-sided polygon. 6-sided polygon is a hexagon, so we would call this a hexagonal prism. Okay. This helps me determine how to find capital B. To find the area of a regular polygon, we use 1/2 ASN. All right, my apothem is 12.12. The side length is 14 and the number of sides is 6. All right, multiply all of those. I find that the area of my base is 509.04 square centimeters. Now, perimeter for regular polygons, we are going to take the side length times the number of sides. To find that perimeter, okay? Because regular polygons, remember, all sides are congruent. So if we have if one side length is 14 centimeters and we have 6 sides, the perimeter of that hexagon base is 84. All right, and then the height of my prism, remember, is how far apart those bases would be. 18 centimeters. Okay. Now, same surface area equation. 2 area of the bases plus the perimeter times the height. Okay, so 2 times that 509.04 plus my perimeter was 84. The height of my prism was 18. And doing that tells me my surface area is 2,530.08 square centimeters. Okay. Number 4, our base is an octagon. So this is, I'm going to write octagon here. This is an octagonal prism. To find the area of our base, we still use 1/2 ASN because this is a regular polygon, okay? Any regular polygon, we're going to use this equation. My apothem is 6.04. My side length is 5, and octagons have 8 sides. So I multiply those, and I get the area of my base to be 120.8 square feet. All right. Remember, to find the perimeter of a regular polygon, we take that side length times the number of sides. So our perimeter of this octagon is 40 feet. And then the height, you need to ask yourself, how far apart are the 2 octagons? Okay, and I know it's hard to tell, but the bottom is also an octagon. So those 2 bases are 12 feet apart. So our height is 12. Okay. Put those 1, 2, 3 variables into our equation. Okay, 2 times the area of my base plus the perimeter times my height gives me a surface area of 721.6, not 1, square feet. Okay. On your practice tomorrow in class, you will have to name the prism itself, not just identify the base, okay? So just remember, we name prisms by their bases. Number 1 would be a rectangular prism, 2, a triangular prism, and then 3, since the base is a hexagon, hexagonal prism, and 4 would be an octagonal prism. Okay, so again, we'll practice that in class tomorrow. But for now, we're going to talk about cylinders. All right, cylinders are similar to prisms. They still have 2 bases that are parallel and congruent. All right, but instead of being a polygon, their bases are circles. All right, the lateral face that we're going to deal with is going to be a rectangle. Okay, but they can also be just general parallelograms. Okay, capital B still stands for area of the base. All right, but since our base is always a circle, to find the area of the base, we will always use pi r squared, because that is how we find the area of a circle. Okay, C, think about C replaces P in this equation, and if P represents the perimeter of a polygon, C is going to represent the circumference of the base of the circle. Okay, and remember, circumference can be 2 things. We can either take pi times the diameter, or we can do 2 pi times the radius, okay, depending upon which piece of information we're given. All right, but H still represents the height. Ooh, that'd be cool if I could spell correctly. Height of the cylinder. Okay, so again, you ask yourself, how far apart are those circular bases? Okay, so we'll do 2 examples here, and then you guys can get onto your DMR. Okay, first example here, the radius of our base is 10. Okay, so to find the area of that base, remember it's always going to be pi r squared for cylinders. Okay, since we're given the radius here, I'm going to use 2 pi times my radius to find my circumference of 20 pi. Okay, and then how far apart are these circles? That's what I need to ask myself when I'm finding the height. Here it's 16 centimeters. Okay, so just like we did with prisms, we're going to use 2b instead of p. We're going to use ch because we have the circumference. 2 times the area of the base plus the circumference times the height. Okay, now when we have pi in here, okay, I want you to think of pi kind of like a variable. Okay, so we're going to take 2 times 100. That gives us 200 pi. Okay, over here I'm going to take 20 times 16 to give me 320 pi. Okay, and then just like if we had, instead of pi's, we had 200x plus 320x, we would combine just those coefficients out in front. We're going to do the same thing. Okay, 200 plus 320 gives us 520 pi square centimeters. Okay. Last example here. Don't know why that P is there. Ignore it. We've got our circular bases. Our radius is 7. To find the area of the base, we take pi times that radius squared. So our base is 49 pi square inches. Okay, circumference, again, I've got my radius, so I'm going to do 2 pi times my radius to get a circumference of 14 pi inches. And then my height is how far apart those circles are. That's 11 inches. So my equation 2b plus ch, since this is a cylinder, 2 times 49 pi, because that's the area of my base, plus my circumference times my height. Okay. Again, we're going to take 2 times 49 for a total of 98 pi here. That represents the area of both bases. Okay. 14 times 11 is 154 pi. That represents, think of it like a soup can label, how much needs to cover that area between the bases. Okay, and then 98 plus 154 gives me a total surface area of 252 pi square inches.